In this video, we introduce the idea of probability distributions. So when we've collected some statistical data, we'll often want to know whether there is a background probability model that describes this data well and will enable us to make predictions about the data in the future. So, suppose a pupil has a spinner that's divided into 12 equal sectors, and each sector is marked with a number. The pupil presents the graph below to illustrate the outcomes of 240 spins. And from the graph we can see that he's obtained scores of 1, 2, 3, 5 and 10. So in fact there are only 5 different numbers appearing on the spinner, but we've got 12 sectors, so clearly some of the numbers are going to appear more commonly than other numbers. So, several different probability models might be possible to describe the scores obtained from this spinner, and the 3 possible models are given below. We've got Model 1, Model 2, Model 3. What I'd like you to do at the moment is just pause the video, have a look at the 3 models that have been described there, and decide which one you think describes the data that we've collected from the 240 spins the best. When you've done that, move on to the next part of the video. So James is going to throw a normal fair cubical die. Let x be the score that he obtains. Well, when we throw a normal fair cubical dice, we're carrying out a random experiment, and it's a random experiment whose outcome space consists of the numbers 1, 2, 3, 4, 5 and 6. A random experiment whose outcome space consists only of numbers is called a random variable. And the probability distribution of a random variable is a table or a rule that gives the probability for each of the possible outcomes of that experiment. So, in the case of the random variable x, which is the score that James will get on his next throw of the dice, then the random variable can take the values 1, 2, 3, 4, 5 and 6, each with probability 1/6. So that is our probability distribution for the random variable capital X. We could say, instead, that the probability that the random variable capital X takes a value little x is equal to 1/6 for little x equals 1, 2, 3, 4, 5 or 6. For a random variable that takes a finite number of values, like this one does, each with the same probability, then the random variable is said to have the discrete uniform distribution. Kathy's got a spinner with numbers marked 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. As shown in the diagram. She's going to spin this spinner once, and y is the number of the edge of the spinner that rests on the surface. What I'd like you to do at this stage is write down the probability distribution of the random variable y and decide whether y has the discrete uniform distribution. So again, pause the video, do that little bit of work, and then start the video off again. Now James is going to throw his dice again, and Kathy spins a spinner again, and T is going to denote the total of James's score from his die and Kathy's score from her spinner. And I've started a diagram showing some of the possible outcomes of this experiment, together with, in red, the corresponding values of T. What I want you to do now is to finish off the diagram showing all the possible outcomes, and then answer the questions. What's the largest possible value of t? Or sorry, what are the possible values of t? What's the largest possible value of t? What's the smallest possible value of t? I want you to write down the probability distribution of t and to decide, does t have the discrete uniform distribution or not? And once you've done that, you've completed this video.